Hello everyone, this is Bharat Kumar, Assistant Professor in Computer Science Engineering at St. Martin's Engineering College. I welcome you all today's online video lectures on setching in C programming. In this video, I will cover what is setching, what are the different setching methods, and we'll discuss with program and output. See, now setching is a process in which we are finding whether the given information or given data is presented in the already existed data or not. If it is present, we are telling what given information is present. For example, if you take some array of elements, if you consider the integers, so 5, 10, 15, 20, 25. Here, these are the array elements. I want to set the number or integer 15 is presented in the given array of elements or not. So for doing this, for setching, we are using setching algorithms. So here we are setching this 15 whether it is presented in the array of elements or not. That is called setching. So if our key element is found in the array elements, then what we can call key element is found. If key element is not presented in the array of elements, then we can call key element is not presented. So there are two types of setching methods: linear setch and binary setch. Now we will see about linear setch. So let me explain with algorithm and program. Linear setch. So it is also called sequential setch. Why it is called sequential setch means we are comparing our key element or targeted element with array elements one by one until our key element is found or array elements are exhausted. So let us see, you take array of elements. For example, array size is 5, n equals to 5. Those array elements are 5, 10 and 15 and 20 and 25. Let us consider our key element is 25. Now in the linear setch, what we are doing, we are comparing our key element with the array of element one by one until key element is found or array elements are exhausted. So see here 25, we are comparing our key element with the first element of array. So let's see index of the array elements 0, 1, 2, 3, 4. So we are comparing key element 25 compare with the 5, not equal. So key element is not found. And next 25 will compare with the 10, not equal. 25 compare with the 15, not equal. 25 compare with the 20, not equal. 25 compare with the 25. Yes, both are equal. So now what we can call key element is found. For example, key element is 30. Again same process, 30 will compare with each element of array. So 30 will compare with 0, 5 and 10, 15, 20, 25. So all are not equal. So key element is not found. For example, key element is 15. 15 compare with 5, yes, not equal. 15 compare with 10, yes, not equal. 15 compare with 15, yes, equal. Now we should stop the comparison operation here. So according to definition of the linear setch, what we are doing, we are comparing our key element with the array of elements one by one until key element is found or array elements will be exhausted. So this is the basic method process to perform the linear setch. So next we will see algorithm. Based on the algorithm, we will write the program. So we taken the elements, so 10, 15, 20, 25, 30. Our key element is what? 15 for example. So I have to compare this 15 with the array of element, each array of element. So one by one. So 0, 1, 2, 3, 4. So n is 5. Size of the array is 5. So what I have to, so first step is what? I am taking flag bit. I will explain you later why I am taking flag bit. Flag I am initializing with 0. So flag is a extra bit. The flag value may be a 0 and 1. Based on that value 0 and 1, we can enable the particular operation, or we can stop the particular operation. So second one, now what we have to do, we have to compare our key element with the array of elements. Every time we are comparing. So for comparing, we are using for loop. So for I equals to 0, I am taking I is an integer for performing the for loop. I equals to 0 to, see here, what is the last element index? 4. So what is the value of n? 5. So n equals to 5. So last element is what? 4. 5 minus 1, 4. So what you have to write here? Up to what? N minus 1. So we have to perform the comparison operation up to 0th index to 4th one. So that's why I wrote for I equals to 0 to n minus 1. If this condition is true, I have to perform the comparison operation. For that, do means what? If this condition is true, we are going inside of this for loop. So what is that? If 2.1, we can call next step. So if our key is equals to a of I, then this is a pseudo code. Of course, we are not following the syntax. So it is like look as a program only, but we no need to follow the syntax. So if key equals to a of I, then I have to update the flag bit. So flag equals to 1, and then you have to stop the comparison operation, break. And then third step, if flag equals to 1, then I am printing what? Print key is found. Of course, we no need to follow the syntax, just this is the algorithm. And the next one, else if this condition is false, else I am printing the message keys not found. This is the algorithm or steps to follow to write the program for linear search. So initially I am initializing flag equals to 0. Then I have to compare our key element with each array element one by one. So for that I am using for loop. So I equals to 0 to n minus 1 up to last element of the array. If this condition is true, we are entering into this for loop block. For loop. So if key equals to that array of element, then flag bit will be changed from 0 to 1. So whenever key is found, we have to stop the comparison operation between key and our array element. So that for that I am using break statement. So after that, if break statement is executed, we are coming out from the for loop. After that, we are checking the flag bit. If flag equals to 1, then key is found. If flag equals to if it is false, then key is not found. And this is the algorithm to perform the linear search. So now let us write one program, C program, to implement the linear search. So what is the first step? You know already, hash include stdio.h Basic header file we have to use since we are using printf and scanf functions. So those functions, the declaration of those functions will be stored in this std, standard input and output header file. That's why we have to add this hash include stdio.h header file. Now main function int main. So in this int main, now to perform the linear search, we need input and output. So now I will declare the input and what is output. Input means what? To perform linear search, we need key value, we need array elements. So input means array elements, and then size of the array size is required, which is denoted by n, and this is array of elements will be denoted by a of, and then key value is also required, key. These are the inputs to perform the linear search. And next, what output you required? Output is what? If key element is, whenever you are comparing the key element with our array of elements, if key element is equals to array of element, then key is found. So if not found means key is not found, just that is output. So input is key is found and key is not found. These are the input and outputs. Now this all key and array elements and size of the array all are integers. That's why I am declaring int n. N is the size of the array, and then the maximum size of the array is what? 10 I am taking. You can take anything, and then comma. Since I am using for loop, so I is the integer, and then key also integer. Then next flag equals to 0. I am initializing before. And now I am using compile time initialization. You have to ask the user to enter the size of the array, and you have to ask the user to enter the array elements, and we have to ask the user to enter the key element. So those are the inputs. So normally we are using printf and scanf functions. So printf enter array size. Then scanf. So user will enter the size of the array, then it will store in n. So since n is the integer, the format specifier for the integer is %d, format specifier, and then ampersand of n. So whatever you are entering the value of array, size of the array, that will be stored in n. So this will indicate the address of n. And then printf enter array elements. So if n equals to 5, for example, you are entering 5 elements. So every time you are taking the array elements, integers we are taking. So for that I am using for loop. So for I equals to 0, I less than or equals to n, then incremented by I plus plus. In for loop scanf, since we are entering the array elements, those are integers, so the format specifier for the integers is %d, and then ampersand of a of I. So closing. So why I am taking I value equals to 0 means the index of the array starts with 0. That's why I took I value is 0. And next we have to ask the user to enter the key value. So printf. So since key is also integer, so for integer format specifier is %d. Sorry, you have to ask the user enter key value and then scanf. So whatever you are entering the key value, that will be stored in key. So format specifier is %d and then ampersand of key. So this is the input. We taking the size of the array from the user. You taken the array elements from the user. You taken the key element from the user. Now you have to perform the comparison operation. So here I wrote here. We have to compare the our key element with each array element. Every time we are performing comparison operation, so we are repeating the instructions, same instructions. So for that we have to use for loop. So for I equals to 0, I less than or equals to n, I plus plus. Then if key is equals to a of I, then flag bit should update, flag should be 1 and then break. And then next again if flag equals to 1, then we have to printf keys found. Else printf key is not found. Close. So this is a program to perform the linear search. So let's see the tracing of the program. So let us the size n value is I am entering 5, n is 5. You have to enter the array elements. So 0th index 1, 2, 3, 4. So the values are 5, 10, 15, 20, 25. You can enter the array elements in any order, sorting order, your wish. So here. So whenever this line will execute, it will ask the user to enter the size of the array. So we are entering n value equals to 5, and then it will ask enter the array elements. So we are entering 5, 10, 15, 20, 25. That will be stored in array, and then it will ask the enter the key value. So that key value is, for example, 20. Now input we got, and then we have to perform the comparison operation. So now see I equals to 0. So 0 first case, 0 less than n value is 5. 0 less than or equals to 5. Yes, condition true. So if condition is true, we are entering into for loop inside of the loop body, and now we are checking the condition. So key, what is key value? Key value is 20. 20 equals to a of 0. What is a of 0? A of 0 is not 5. 20 equals to 5. Not equal. So condition false. So if condition is false, this if block statement will not execute. And then again the I value will be updated from 0 to 1. 1 less than or equals to 5. Why? Because we incremented I value by 1 only. I equals to I plus 1. So now I value is equals to 1. So 1 less than or equals to 5. Condition true. Again we are entering into loop. So and then key value is what? 20 equals to a of 1. What is a of 1? A of 1 is what? 10. 20 equals to 20 equals to 10, not equal. So condition false. We are coming out from the loop again. Again I value will be update from 1 to 2. 2 less than or equals to 5. Condition is true. So we are entering into if block statement. So again we are checking the condition. So this key value is 20 and a of 2. What is a of 2? 15. 20 equals to 15. Condition false. We are not entering into if block statement. And next again I value will be updated from 2 to 3. So 3 less than or equals to 5. Condition true. And then we are entering into for loop. So now, this for loop statement condition we have to check. Now 20 equals to a of 3. What is a of 3? 20. 20 equals to 20. Yes, condition true. So whenever this condition is true, we are entering into if block statement. So what is the block statement instructions? Flag. So initially the flag bit is initialized with 0. Now the flag bit will be updated from 0 to 1 and then break. Break means we are, whenever this break statement will execute, forcibly we are coming out from the for loop. That is the purpose of break statement, already we know. Now if we are checking again this condition, if flag equals to 1, yes, flag equals to 1, updated value. So we are printing this statement, key is found. So this output you will get. For example, key element is 30. Key element is 30. Key element is 30. 30 if we take. So here 30 equals to a of 0. 30 equals to 5. Not equal. Condition false. And then again, when I equals to 0, this here I equals to 1, and then 30 equals to 10. Yes, condition false. This if block statement will not execute. Again, whenever I value is updated from 1 to 2, I equals to 2. In this condition, 30 equals to 15. Yes, condition false. We will not enter into if block statement. Again, I value updated from 2 to 3. So that time 30 equals to 20. Condition false. It will not enter into if block statement. And now again I value is updated from 3 to 4. I equals to 4. So key is 30. A of 4. What is A of 4? 25. Condition is false. And then I value will be updated from 4 to 5. So here 5 less than or condition. Okay. I value is 5. So when I value equals to 4, 30 equals to A of 4. A of 4 means what? 25. So we should use, right, you should add here less than only. Okay, this condition. So 5 less than 4, condition false. Condition false. So we are coming out from the for loop. So now we are checking the condition of statement of value of flag. So if flag equals to 1, no, since already flag equals to 0, flag bit didn't initialize. Flag bit will be 0. So key element is not found. So this is the output. So this is about a linear search. So now we'll explain the linear search with a small video. Yeah, so this is about a linear search with a program. I think you understood about a linear search, how to perform the linear search. Now I will explain linear switch with a small animation. So we are taking 10 elements here. Our key element is 78. So we will compare, first we will compare 78 with 18, not equal. And next we will compare the 78 with 42, not equal. Again we are comparing 78 with 28, not equal. Again we are comparing 78 with 96, not equal. Again 78 will be compared with 5, not equal. And then again 78 will be compared with 81, not equal. Again 78 will be compared with 2, not equal. So sequentially it is comparison. Finally 78 with the compare with the 78, so key element is matched, so both are equal, so key element is found. So we can tell key element is found, search completed. So here we are stopping the operation. Let's see about more about linear search. Time complexity. Time complexity. Time complexity, which is denoted through T of n. So what is time complexity means? How much time the algorithm is taking to execute. That is called time complexity. So there are three cases here, time complexity. First case is best time complexity. Second one is worst case. And third one is average case. Best case time complexity means if algorithm required minimum amount of time to execute, then that is called best case time complexity. If algorithm will take maximum amount of time to execute, then that is called worst time complexity, first case. And then if algorithm will take not maximum and not minimum time to execute, then that is called average time complexity. So for linear search, when it is having best time complexity, for example, you taken 5, 10, 15, 25, 30. If key element is 5, if key element is first element of array, then that time the linear search will have best case time complexity. So in this case we required one comparison only. So the time complexity we can write big O of 1 for, if you see the worst case. So when this linear search will have worst case time complexity means if key element is last element of the array, then that case linear search will have worst case time complexity O of n comparisons we require, n minus 1 comparisons we require. Average case, if key element is not first element and not last element of the array, and then in that case linear search will have worst average time complexity. So for average time complexity also we can denote with the big O of n. So best case time complexity for the linear search is big O of 1. Worst case time complexity for the linear search is big O of n. Average case time complexity is big O of n. So I think you understood about linear search. Thank you so much.